In this video, we are going to solve some problems based on capacitor. There are two identical capacitors which are connected to identical batteries as shown in the diagram below. What is true about the two circuits? So the first circuit is a series circuit, and capacitance formula for series is 1 over C equal to 1 over C1 plus 1 over C2, and for parallel it is C1 plus C2. So the first one, it says equivalent capacitance of circuit 1 is the same as that of circuit 2, which is wrong. Second one says circuit 1 has greater equivalent capacitance. Equivalent means total capacitance. So we can see that in series it's 1 over C1 plus 1 over C2. So the answer which we'll get for series will be less, and for parallel it will be more. So circuit 1 is not greater than circuit 2. So second statement is also wrong. Energy stored. So now the next one is asking for energy stored. So let's write the formula for energy. And I'm going to choose this formula for energy because it says that they are connected to identical batteries. So the voltage remains same. It's the same voltage because they are identical batteries. So that means the energy is going to depend on the value for total capacitance. So we already said that the total capacitance for the parallel is more. That means the energy stored in the parallel should be more. So the sentence C says that energy stored in circuit 2 is same. That is wrong. It's not same. Energy stored in circuit 2 is greater. Yes, a parallel circuit will store greater energy in this case. So our answer is D. Okay, energy stored in circuit 2 is greater than that stored in circuit 1. Okay, so one thing which we need to remember, the capacitance value in parallel which we get with this, if you have identical capacitors, then the capacitance in the parallel will be greater than the capacitance in series. Now here similar question we have got. So there are two diagrams. So first we need to identify which one is in series and which one is in parallel. So for that I'm just going to draw the current direction to see whether current is going to split or not. So in the first diagram you can see that the current starts from the battery, reaches the junction, and then it splits. That means the first one is a parallel circuit. In the second one, there is only one loop, one current. That means that's series. Now we can get the formulas for both of them. I've just rewritten the formula. It's asking you how does equivalent capacitance for these two cases compare. We already said that in parallel the capacitance is more than that in series. Next is asking how does total charge stored in capacitors for these two compare. Total charge, the charge formula is CV. So in this case it's asking for total charge. So total capacitance multiplied by the battery voltage. And it's the same battery, you can see that it's the same battery which is connected. They have represented it with the same symbol. So C total is greater for the parallel circuit. That means Q total will also be greater for the parallel circuit. Then it's asking how does voltage drop over C1. So we want to focus on C1. This is C1. Here C1. Voltage drop for C1 for these two cases compare. Now in parallel the voltage remains the same as that of the battery. For each capacitor the voltage will be same. So C1 in parallel is going to get the total battery voltage, but in series it's going to be shared. So C1 and C2 in series, they will share the battery voltage. That means the voltage drop on C1 in parallel will be more because it's going to get the total battery voltage. So it will be more than that in series. Now here we have got another problem which is having two capacitors and then there is a switch. It's asking you when switch S is closed, what is the charge on 4 microfarad. So if switch S is closed, we will have the current from the battery. That means we will have the current going through the outer loop. So 12 microfarad will not receive any current because switch S is closed. So there is a short circuit. The current from the battery will go through the switch side which is closed, go through the 4 microfarad and back to the battery. So that's the loop which is going to be followed. So you have got only one capacitor which is being used, which is 4 microfarad. So it's asking for the charge. We will use the formula for charge. The battery voltage will go to one capacitor which is 4 microfarad we can multiply it and get the answer for charge. Okay, so here what we need to remember is, because the switch is closed, so the current will go from the battery and it will go straight like this. It will not go into the capacitor because it has got a shorter path, because there is no it's a short circuit. We have connected the switch, so it's a short circuit, so the current will go from the outer circuit and it will come back to the battery. So that's the loop which is going to be followed. Then next, when switch S is open, so just like as it is in the diagram, switch S is open, what's the voltage across 12 microfarad? So that's the loop which is going to be completed. We have now got both the capacitors connected. So we want to find what's the voltage across 12 microfarad. It's a series circuit, single loop, so the voltage of the battery is going to be shared. So to find the voltage across 12 microfarad, we want to know what's the charge which is flowing through the circuit. Because it's a series circuit, the charge will remain constant. Whatever is the total charge will be the same charge which is for each of the capacitor. So first we'll find the total capacitance using the formula for series, and then we'll find the total charge. Okay, C total will be used there, and the battery voltage, and we get the total charge which is flowing through the circuit as 36 times 10⁻⁻⁶ coulomb. Now that's the total charge through which will be for both the capacitors. Like, it's the same charge which is going through the circuit. It's a single loop. So when we find the voltage across 12 microfarad, we are going to first rearrange the formula for capacitance. C equal Q over V. So V will be equal to Q over C, and we'll put the total charge value which we have got, divide by the capacitance value which is 12 microfarad, because we want to find the voltage across 12 microfarad, and that will give us 3 volt. So what we need to remember here, because it's a series circuit, the total charge and the charge for each capacitor is same. In series, the charge remains the same. So we use the total charge value and we use the capacitance of 12 microfarad to find out what's the voltage drop across 12 microfarad.